So good evening everyone. We'll start with the session. So this is the session for week 11 of the course Urban Transportation Systems Planning. So we have reached almost the end of the course now. So after this there will be one more session in week 12. So Urban Transportation Systems Planning. Welcome to the NPTEL session for week 11. I am Abhishek Raj, a PM-RF scholar in the Department of Civil Engineering, IIT Madras. So firstly, we will start with the overview of this session, and then we can take the practice assignment and we can take some doubts. So starting with the overview, so we'll see the content which was taught in week 11. We'll see a basic overview of that, and we'll cover the practice assignment, and then we can take on some doubts. Coming to the overview, so this week was divided into 5 lectures. So lecture 1 was about land use and land cover. So we'll see some questions on this to make this more clear. Then the topic of accessibility was discussed. So how easy it is to reach a certain destination within the city. Lecture 2 was where accessibility was clubbed with mobility. Now we analyze these two aspects together was discussed. Then different types of accessibility models were discussed, such as Hansen's accessibility model, then density saturation gradient method, Putnam's model. And lecture 4 was about Lowry's model, and then some examples and limitations were discussed for the different models. Then when we discussed the lecture 5, so it was about the goods movement, and the basic consideration of the goods movement were discussed, followed by the classification. So we'll start with the practice assignment. This is the first question. Accept or reject the statement. Land use allocation is done before trip generation of four-step transportation planning process. Accept or reject. Can I have a response for this? Okay. So when we talk about land use allocation, so land use is basically we try to categorize the land based on the socio-economic activity. So it can be residential, can be industrial, can be commercial, or educational use is also possible. So many such uses are there. Depending upon the use, we'll try to assign it. So when we know that, okay, this land is used for residential or educational or industrial or commercial, so generally we can predict a trip rate for each of these land uses. So if we have the land use for educational, we can predict the trip rate as T1, let's say T2, T3, T4. This will be per person. So per person from these land uses, this many trips will be made. So once we know the land use, we can determine trip generation, then we can determine distribution, then mode choice, and then finally we can make route choice. So firstly, we need to have the land use. Then only we can start with the trip generation process. So when we talk about land use allocation, so it is done before the trip generation of the whole step transportation planning process. So once we have the land use, then only we can start with the transportation planning process. So the answer here is option A, accept. So the answer is accept. So land use allocation is done before the trip generation, as it is a major input to trip generation, because we need the data of this for trip generation. So we'll see the slide here. So we can see the comparison between base year and horizon year, that is not very relevant here. So what we need to understand is, so first we need to have the land use models. Based on the models, we'll have the land use allocation, and then this will be fed as a input to the trip generation. Although the direction of arrows is different here, but what we do is we try to predict the land survey. Based on the land survey, we feed it to trip generation. So we can also feed it back to the horizon year, and then when we see for the base year only, so we can see here like we have done the land survey, then we are feeding it as an input to trip generation. So first we will do land survey, then only we can start with transportation planning. So coming to question 2, accept or reject the statement. So the question is, freight demand analysis is complicated when compared to passenger demand analysis. Accept or reject. So can I have a response? As question 2. Okay. So freight demand analysis is complicated when compared to passenger demand analysis. So the answer for this is accept. It is true. So let's see it how. So the thing is, in freight demand analysis, different aspects come into the picture, such as movement on goods route is required. So what are the highways or the roads within a city where we can transfer the goods? So that data should be there, because in most of the major cities, the movement of trucks, it is restricted in daytime. So that is the reason we don't see many trucks in the daytime. Within the city, there may be some movements, but from outside the city, they cannot come into the city within the daytime. It is restricted because they can create traffic. So movement on goods route. So how is the movement? What is the time? These things affect. But when we see passenger demand analysis, there is no such constraint. They can get out any time, any day, any route they can pick. But it is not the case for goods routes, because in goods route we have a specific time, specific route, because on every road a truck cannot go. A truck needs a wider road. So single lane road, intermediate lane roads, those kind of roads a truck cannot take. But a passenger vehicle can easily go into a small roads also. So those kind of constraints don't come into picture for the passenger demand analysis. So any time, any day, any route they can take. But for trucks or goods vehicle, it is different. Then another factor is the location of freight terminals. So there will be different. So if you have the city, so there can be different points where there will be the freight terminals. So there can be road in between them, or there cannot be a road. So they will have to take a longer road that way. So these things also need to be considered, where the terminals are and where they need to drop or load the luggage, load unload they need to do. So those factors also come into picture. These kind of constraints don't come into picture for passenger demand. So that's what makes freight demand analysis more complicated when compared to passenger demand analysis, because there are certain factors which we need to consider. So the answer here is accept. So the answer is accept. So you can see here, so goods movement demands are created by the economic activities of production and consumption, so which is obvious. So we have to identify the principal economic units in urban area and understanding of their internal structure and the commodity movement demands. So here we can see what we studied just now. So freight demand analysis is much more complex than passenger demand analysis, as it is influenced by factors related to routes to be used for good movements, location of freight terminals, and sometimes we have to segregate the goods into small assignments for distribution within the urban area. So if we have a big truck, so sometimes the truck will transfer its load into two small commercial vehicles. So for that also they need terminal, there will be a place to do that. So these factors come in picture. So that's what make rate demand analysis, which is much more complex than passenger demand analysis. So this is the key takeaway. Coming to question 3, which of the following statements are correct regarding land use and land cover? Land use represents location of different types of socio-economic activities. Land cover can be determined by using satellite imagery. Land cover refers to both natural and artificial cover on the ground. For a given land cover type, only a single land use is possible. Can I have a response for this question 3? Okay. We'll see the answer now. So which of the following statements are correct regarding land use and land cover? So land use represents location of different types of socio-economic activities. This is what we discussed in question 1 also. So there can be different land use. So depending upon the type of socio-economic activity, it can be residential, can be industrial, commercial, and so on. So based on the type of activity that is taking place on that piece of land, we can assign it a land use. So this land is industrial, this land is commercial. So this is correct. So option A is correct. Then land cover can be determined by using satellite imagery. So this is also correct because nowadays we have Google Maps. So where even Bing Maps is there, different kinds of mapping softwares are there. So where we can see the satellite image of a place, it will not be very accurate in the sense it will not be very updated. It will not be a satellite image of today. So it may be somewhat old, like 2 weeks or a month back, but it will be very precise. So in satellite we can easily see we have a city and we are seeing it from the top down view, from the satellite's top down view. So it will click pictures of the area, so we'll have everything. So if we can see that okay, there is a big place here, but there are no houses, so it can be maybe an industry or a commercial place. There are many small houses in a place, so maybe it is a residential area. There are big small, so maybe it is a commercial area. So in a place there are only trees, so there maybe it is forest cover, that is natural land use. So depending upon the type of cover you can have. So there can be two types of cover, land cover. That is, first is we can have natural. It is there will be forest, or there can be say barren land. There is nothing there, simply there. Or there can be some river, ponds, anything like that. That will come in forest natural cover. Then we can have artificial. That is human made. So where we can have like house, factory, different kinds of things can be there in artificial cover. So land cover can be either natural or it can be artificial. So we can easily determine this with satellite imagery because we can see what is there, so we can determine. So B is also correct. Then land cover refers to both natural and artificial cover on the ground. So this we just discussed because natural cover can also be there, artificial cover can also be there. So C is correct. Then it is given for a given land cover type. Only single land use is possible. So no, this is not correct because if say we have a piece of land, we can easily divide it into say a residential land and a commercial land, half half. Why there should be only a single land use? That is not very correct because we can same land. If we have a certain land cover, we can convert it based on our requirement. There is nothing like only single land use is possible. So there's nothing like that. So let's take the correct options. So option A is correct. So different socioeconomic activity, there can be different land use. Then if we have a city, we need to determine the land cover. We can use satellite imagery. So B is correct. Then land cover refers to both natural and artificial cover. So C is correct. And finally we have D. So D we can remove here. So D we can cancel. So A, B and C are correct. So option A, B and C are correct. So land use represents location of different types of socioeconomic activities. It can be determined using satellite imagery and there can be both types, which is natural and artificial cover on the ground. So option A, option B and option C are correct. Coming to question 4, which of the following statements are correct in the context of mobility? So we'll see 4 options and then we have to choose the correct ones. Average number of trips per person is a rational measure of mobility. Second option is in urban transportation planning, integration of accessibility and mobility is not needed for better planning. Ability to move out depends on car ownership and family income. And if a person is free without many ties or responsibilities at home, his or her mobility can be high. Can I have a response for question 4? Okay, let's see the answer. So first is which of the following statements are correct in the context of mobility? What is mobility? Is like the how much mobile is someone, like how much easier it is for a person to move from one place to another within the city. That is the simple definition. So average number of trips per person is a rational measure of mobility. So this is not correct because like considering how much trips a person is making in a day, that may not be the uh, like you can say accurate measure of mobility because the person may be just making like say 5 trips within his neighborhood itself. Like he goes in morning for a walk, he goes in maybe around later morning for to bring some groceries. He goes later sometime. If let's say assuming the person does not do a job, then there can be multiple trips within the same locality. But considering that like this person is making 5 trips, so he is very mobile. So that is not true because he is making all the trips within the same neighborhood. If we compare it with a person who is making one trip but he is going far away, but that is a different picture, all right, because so same person is there but he's going very far, and the same person he is making 5 trips within the same locality. So average number of trips per person, it is not a very good measure to take because different things are possible. So we'll see in more detail why is this the case. Then in urban transportation planning, integration of accessibility and mobility is not needed for better planning. So this is also we can remove because accessibility matters. Just going to a place is not mobility. Like there, the picture of accessibility will come into place because how easy it is to reach from one place to another. That will also affect the situation because If there are roads, there is public transport, we can easily reach from one place to another. But if that is not the situation, accessibility will be less, so mobility will be less. So we need to club accessibility and mobility together to get the full picture of transportation planning. So C we can remove. And ability to move out may depend on car ownership and family income. So this is true, because if someone has a car, he can go to far away places easily. If family income is higher, we can travel more. So if family income is high, they can take their personal vehicle, they can go far away. So it is correct. So C is correct. If a person is free without many ties or responsibilities at home, his or her mobility can be high. So this is obvious, because if a person is free, like he can travel to far away places, but he has responsibilities at home. He cannot go very far. He needs to come back quickly. He needs to make shorter trips. So in that case, mobility will be affected. So let's take the correct options first. So which of the following are correct? So C is correct. D is correct, because car ownership is there, family income is high, so ability to move out will be high. Then person is free, does not have commitments at home or office. He can make more trips. He can then go to far places. So mobility will indirectly increase. So C and D is correct. A and D we can remove. Those are not correct. So A we can remove. B we can remove. So C and D are correct. So here we'll read the description and try to understand. So mobility measured in terms of average number of trips cannot be. So everything cannot be a rational measure, as there are many disadvantages of mobility measured in terms of per capita. As I discussed, so there can be different situations which are possible. So per capita is not the correct measure to take. So this was related to option A. Then mobility and accessibility together influence an individual's capability to travel in daily life, and so a close integration of both accessibility and mobility is needed for better planning. So this is related to option B. Then ability to move out depends on car ownership and family income. So this is dependent on option C. So we have the dependence on car ownership, family income. And mobility refers to the degree to which a person is free. This is related to option D. So how mobile is the person, how free is, that is option D. So all four options we have discussed. So only option C and D were correct, A and B were correct. Coming to question 5. Which of the following statements are incorrect in the context of mobility? So here we have to determine the incorrect statements, not correct. Option A, improvements in the transportation infrastructure can improve the accessibility of the region. As accessibility increases, mobility in terms of distance traveled increases. Higher the travel time between places, greater is the accessibility, and improvement in accessibility to a place does not cause any change in the respective land use. You can read the question and give me some response for question 5. We'll discuss that. Okay. Let's see. So first is improvements in transportation infrastructure will improve accessibility. So this is true. We are providing more number of buses, better roads, so it can improve the accessibility. So this is true. So this is basically a correct statement. Then accessibility increases, mobility in terms of distance traveled will increase. So this we can remove, because if we can go easily to some other far away place, so mobility will reduce because we may not want to travel too much in that case, because when we can easily go to far away places, we'll quickly come back. So mobility will reduce with increase in accessibility, and higher the travel time between places, greater is the accessibility. So no, this is not correct, because if we want to go to another place in the city which takes 1 hour to go, we may not prefer to travel there. We will choose the same another place with the same purpose, somewhat closer. So the accessibility of that place is reducing due to more travel time. If a place is 10 minutes far, it is more accessible. If a place is 1 hour far, it is less accessible. So here the relationship is directly proportional, but in reality it is inversely proportional. So higher is the travel time, lower will be the accessibility. So C we can remove. Then improvement in accessibility to a place does not cause any change in the respective land use. So this also we can remove, because if a place in a city is more accessible, so in that case what we can do is, a place is more accessible, so land use pattern will change. That the reason for that is because if land use is changing, so the person will want to travel there more. So if say let's take the example of a city. So we have a residential area here, here, and here. Let's say we have the CBD. So this place is easily accessible from all residential areas. So the probability of a market getting developed will be much higher, because from all places in the city, people can get attracted to the center. So from A, B, C, and D, everywhere people can come to the CBD. So based on the accessibility, the land use pattern will change. Here it is written, it will not change. So we can remove. So in this case, we need the incorrect statements. So B is incorrect, C is incorrect, D is incorrect. But we can say that A is correct. So we can remove A. A we can remove. So B, C, and D are the incorrect statements. So that is our answer. So option B, C, and D. So as accessibility will increase, mobility in terms of the distance travel increases. So this was one of the options. So this is incorrect. Then higher the travel time between the places, greater is the accessibility. So no, this is not, because it will be lower. We can change it. This also we can remove. It will be reducing. Improvement in accessibility does not cause any change. So we can remove this. Does not. So it will cause change. So answer 5 was B, C, and D. Coming to question 6. So we have the data here. We have the table. So I'll just explain. So we have city with 3 residential areas, R1, R2, and R3. So we have been given the population of workers, 2000, 3500, and 3000 workers, and 2 employment zones, E1 and E2. So we have 3 residential areas, R1, R2, R3. We have 2 employment zones, E1 and E2. So here we have 4500 and 4000 job opportunities. The interzonal travel times in minutes are given. So 8, 10, these things are the travel times, 6, 12, 10, 14. Find the zonal accessibility of R1 as per Hansen's model. You have to assume the coefficient B to be 2. Then round it off to nearest integer. So you can try this question and let me know the answer. Okay, that answer is not correct. Maybe you can check your answer. Try again once. We'll discuss in maybe another 2 minutes. Any other response? Okay, let's see. So we have all the data. So let's try to solve the question. So what we need is the accessibility for zone R1. So accessibility is given by the trip interchanges divided by dij power b. So here d is nothing but the cost of travel. This is the interzonal travel time, that is d. B is the coefficient or the power is given in the problem. Eij we have to find. So we need for zone 1. R1 we need. So firstly we'll do A11. So we have to, first what will happen is, so from R1 we will have 4,500 trips in total, because it will, only 4,500 can get attracted to R1 from R1 to E1. So that will take. So firstly we'll take the total E value, basically ED. So for this column we'll take 4,500 divided by, we'll take Dij. So we have to go from R1 to, let's say firstly we are going from R1 to E1. We'll live there and we'll work here. So R1 to E1 we'll get, so 8 So 4500 by 8 square. So this is nothing but, let's write the full thing. So A11 will be E1 by D11 square. Let's calculate this. This is coming out as 70.31. This is first. Now let's find A12. So this will be E2 by D12 square. So what will be E2? We'll take 4000 here. Because now we have to take for zonal employment 2. So how many can get there and based on how much distance? So for 4500 can go to employment zone 1. And for E2, how many can get? So 4000 can go. Simple. So we don't even need to see like how much is how many people are living here, how many people are living. That does not matter. What matters is that at the destination, how many people can come. So first zone 4500 can come from zone R1 with a travel time of 8 minutes. So we did that. For zone 2, 4000 can come. But if they are coming from zone R1 zone, so we'll divide it by 10 square. So this will be 40. So this is 2. So adding 1 and 2, that will give us the accessibility total. So I hope this is correct. So zonal accessibility of R1 here. So A1 will be equal to A11 plus A12. So we can add them. 70.31 plus 40. This will be 110.31. We can round it off to 110. This is the answer. 110. So is it clear? Okay. So we'll move ahead now. Moving to question 7. Land use allocation can be done at any stage of the four-step transportation planning process. It's true and false. Can I have a response for question 7? We have discussed this. Okay. So as we discussed, so land use allocation we cannot do at any stage. We have to do it before we do the four-step transportation process because the land use allocation, it goes as an input into trip generation. So for doing something, if we need an input, how can we do it after that? So if for doing work B, we need A. So first we have to do A. So land use allocation cannot be done during any stage. We can cut this out. So it is false. So false is correct here. So the answer is false. So we can see here, first we did the land survey and the input from land survey goes into trip generation. Then only we can find the trip rates. Once we have the trip generation, then we can project it, the land use in the horizon. This was question 7. So these are the 4 stages. So first we did trip generation. Then we can do modal split. So here we are doing mode split before distribution itself. So we can do after also. Then do distribution and finally we'll have the full assignment. Coming to question 8, location of facility population is decided based on the availability of service facilities according to Henson's accessibility model. True and false. Okay. Okay. So when we talk about Hansen's accessibility model, we take into account the employment. We don't consider the. So here we need to determine location of population. So they are saying based on the availability of service facilities. So no, this is not correct because in Hansen's model we consider the employment and then only we can determine the that like whether the employment opportunities are and based on the employment opportunity where the population will be residing around it. That is Hansen's accessibility model. This is false. Let's see this somewhere because we use it in another question also. Answer is false. So in Hansen's model, total employment is considered to be the predominant factor that determines the location of population. So how many employment opportunities are there that will determine the accessibility and we can get the where the population will live. So Hansen demonstrated that locations with good accessibility had a higher chance of being developed at a higher density than remote locations. So we can predict the location of population considering the employment of at the predominant factor in determining the location. So wherever employment opportunities are there, more people will live in the those locations and around it. So he suggested that accessibility index is given by employment opportunities by Dij power B. Coming to question 9. So we have a accept reject type of question. So as per Lowry's model, location of basic employment is decided based on the location of population serving employment. Accept and reject. Okay. So what we are saying here is location of basic employment is decided based on the location of population serving the employment. But what is done here is so first previous question was about Hansen's model. So here based on the employment we decide the population. But here what we do is so we fix the basic employment. So here we are saying location of basic employment is decided now. So it is not decided based on any factor. So we just fix it based on how we fix it, and then we will have some variable employment, and that will decide the population. So we can reject it. So answer here is reject. So the answer is reject. So basic employment location is fixed. Based on that, the population serving employment is allocated endogenously within the model. So let's see. So basic employment is the employment in those industries whose products or services depends on markets external to the study area. So here those industries only will consider where the market is external. So that is the market for those industries is not within the study area, it is somewhere outside. But that is basic employment. Then service employment will be it will depend on the population distribution within the region. So how it will be spatially distributed will be allocated exogenously for basic employment and then based on the constraints we can satisfy the serving employment and minimum population. So that is Lowry's model. Coming to question 10. So here we have the data. So a small city consisting of three zones with 4,000 employment opportunities are distributed as 1,000, 2,000 and 1,000 in zones 1, 2 and 3. If A is 2 Calculate the number of residents in Zone 3 as per Putman's model. Assuming that there are 4,000 heads of household living in the city, the costs are given. So you can try this and let me know the answer. Maybe I'll give 2 to 3 minutes for this. Any response for question 10? Okay, you can check the answer once. I'll give 1 more minute. discuss. This answer is not correct. Okay, we'll see the answer now for question 10. So we have the data. So let's see the data again so that we don't go wrong anywhere. So we have three zones. We have 4,000 employment opportunities. So zone 1 has 1,000. Zone 2 has 2,000. Zone 3 has 1,000. The coefficient is 2, alpha, or we can take it as alpha maybe. Then calculate the number of residents in zone 3 as per Putman's model, assuming there are 4,000 heads of household living in the city. So the costs are given. We have the costs. Let's start. So if we have to find, so NI will be given as summation over J, the employment opportunities in J, and how many people will travel. That is PIJ. So here we want for zone 3. So from zone 3 we have to see. So if we want to find P, yes, the change it. We have to find say P31. So that will be given by, so first we'll take 3, then we have to go from zone 3 to zone 1. So it will be C31 power minus alpha divided by C31 minus alpha C11 minus alpha. So from all zones 1, 2, 3, everyone can go to zone 1. So C21 power minus alpha. So let's see this. So 3 1 is 2.5 power minus 2, 2.5 power minus 2 plus 1 1 is 1 power minus 2, 2 1 is 2 power minus 2. Let's find all the values. So the numerator is 0.16, 0.16 plus 1 plus, I think this will be 0.25. This is coming as 0.11. So this is for P31. Let's do it for the next one. So that will be P32. So here we have to see from zone 3 to zone 2. So we'll take C32 minus alpha. So whatever is coming here will come here in the numerator, and this, the sum of all the three will come in the denominator. So C32 minus alpha, C12 minus alpha, and C22 minus alpha. So wherever we want to go from each zone, we'll take 3, 1, 2. So we'll take the sum. So 3 to 2 is 1.5 power minus 2, 1.5 power minus 2 plus 1 to 2 is 2 power minus 2, and 2 to 2 is 1 power minus 2. So 1 by, this is coming as 0.44, 0.44, 0.25, and this will be 1. So this will be 0.26. Now we have one more. So let's take it as P3, 3. So that will be C3, 3. So we can go from 3 to 3 minus alpha, C3, 3 minus alpha, C1, 3 minus alpha, C2, 3 minus alpha. So this will be 1 power minus 2, 1 power minus 2, 1.5 power minus 2, and 2.5 power minus 2. So the order is changed here, that we can, won't matter. So 1 by 1 plus 1.5 power minus 2 is 0.44. So we found it here. 2.5 minus 2 is 0.16. So we should be aware while we are doing calculation so that we don't have to do these things again. So we should remember that, okay, we found this 1.5 power minus 2, so we can directly put here, we have found it before, which we can put it here. So this reduces the time taking in the calculation. So 1 by will be 1.6. It's coming out at around we can round it off 0.63. So now we need the number of trips. So we need for zone 3. So let's do it. So M3 will be equal to, we'll take first E1, P31, E2, P32, E3, P33. So you can see here. So we need it for zone 3. So I will be 3. So I will be 3. That is I is fixed. J we can change. So there are 3 zones. So J will be 1, J will be 2, J will be 3. So there will be 3 terms. Where I will be 3 and J will change from 1 to 3. So we have to do the sum because here we have the summation. So let's do E1. So we need the values. So 1000, 2000 and 1000. So 1000 into P31 0.11. Next is E2. E2 is 2000. P32 0.26. Last is E3. So that was also, I think, 1000. Value is 0.63. So let's do the, so 1000. So this will be 110. This will be, I think, 520. This will be 630. So 1100, 1200, 10, 20, 30, 60. So 1260. That will be the number of residents in zone 3 as per Fortune model. And 3 we have obtained. So any doubt?
Clear.
So we'll move on to question 11 now. Simply, we need to find the value of P for all the 3 zones. So one zone origin is fixed at 3. So we'll change the destination 1, 2, 3. So all 3 combinations we found, then we can multiply it with the employment opportunities or the number of workers. It is same in this case. So and then we should take the sum. We'll get the total. Moving to question 11. So this is the answer. I'll just mark it. Question 11. According to Putnam's model, in a steady area with certain zones, percent of population living in a zone with respect to workplace zone decreases with increase in relative cost of travel between the zones. True and false. Can I have a response for this? Okay. So, according to Putman's model in a steady area, so just now we saw, so let's take example of 3, 1. So what was 3, 1? It was C31 minus alpha, C31 minus alpha, C32 minus alpha. Be wrong. So no, yeah. So it will be change it. It will be 1, 1 into 1 minus 2. So we have the formula for finding P. So if the cost increases, what will happen is the numerator will reduce, because if we have 2 power minus 2, it will be 1 by 4. That will be around 0.25. But if the cost is 3, that is the cost is higher, so it will be 3 power minus 2, that is 1 by 9, it will be around 0.11. So we can see that the numerator has reduced. So P value will reduce. If P reduces, the number of people living in a zone will reduce, because it is dependent on P into E. So if P goes down, PE will go down, so the total value will also come down. And it is, if even if we see it logically without going into all this formula, so if we see, so if the relative cost increases, that is, if there is a workplace and from there someone lives 20 kilometers far, so it is very less likely that people will try to live there, because it is 20 kilometers. It will take 1 hour to go, 1 hour to come back. So it will take too much travel time. So they will want to locate somewhere closer. So the higher is the cost of travel, the lesser number of people will live at that distance. It's simple, because even if we see it simply, so if we have the central business district of the city, so the farther we go, so at the edge of the city, very less people will live. More people will be concentrated closer to the CBT. So as we go further, it will start reducing, because travel time will increase. So it is true and false. So we can select true here. So true is correct, because percent of people living in a zone will decrease with increase in the relative cost. Further we go, less people will live there. And it is evident from the formula also. We can use the simple logic also. So that is question 11. Answer is true. So we can see here Putman's model's equation. So Cij is the cost of time of travel between I and j. So Cij power minus alpha. The lower it is, the numerator will become lower. The value of f will reduce, and number of people living in that zone will also reduce. Coming to question 12. Which of the following statements are true regarding density saturation gradient method? Lesser the distance of a place from CBD, greater is the population density. This method is widely used to forecast future land use structure. Lesser the distance of a place from CBD, greater is the intensity of land use. It is assumed that land use allocated to each type of land remains constant with time. So you can try it and let me know the answer. Any response for this? Okay. A, C, and D. So here I think this is repeated and change it to maybe. So we can. So first, let's start. Lesser the distance of a place from CBD, greater is the population density. So as we discussed, so we have CBD. Let's say we have the city boundary. So the closer you are, the more people will live here, and the farther you are, less people will live here, and the outskirts, very less people will live. So as we go farther from CBD, less people will live because the travel time is increasing. Although nowadays the preference of people is changing. Some people prefer a farther place also because cost of living is cheaper there. But talking from a purely a transportation point of view, so the closer we are, the more people will live there. So lesser the distance of a place from CBD, greater is the population density. So A we can select. So I think C also was same. So we can, but we can remove C here because it's greater. We can change it to lower, so we can remove C. So this method is widely used to forecast future land use structures. So this also we can remove. It is not correct. And it assume that land use allocated to each type of land use remains constant with time. So yeah, this is true. So this is one of the assumptions in density saturation method. So what we will do is, so we'll assume that how much land we have allocated to each type for commercial, industrial, educational, whatever type we have allocated. So with time it will not change. So that is, if residential has 20%, it will have 20%. Well, it will not start expanding because that will change our calculations. So that is one of the assumptions that is made. So A and D we can select. So since A and C are same, so both are true with A, C, and D. So less closer we are to CBD, greater will be the population density. So both these were true. And land allocated to each type of land use remains constant. So this also is our assumption. Just mark it with green. So here we can select A and B. We can remove C. C is not needed. Question 13. So we have been given a city with three zones. All three are at equal distance from CBD. So we should consider this. All three are at equal distance. What is the existing percentage residential saturation of the city? So we have the data. So we have zone wise data. Change the color. So we have zone 1, zone 2, zone 3. We have residential population in each zone. How much land is getting used, how much land is vacant, total population, total land use, and total vacant land available. So you can try this. Let me know the answer. Any response? Okay, we will discuss the answer. 65. Okay. So see, so we have the data. So we have to find the residential saturation. So let's find the residential density. That is, how many people are living per square kilometer. So this will be total population divided by existing land use. So this will be total population is 16,000. Existing land use is 270. So how many people are living per unit land? So let's find this. So it will be around 59.25. Let's call it persons per square kilometer. Now, what we have to find is residential saturation. How many people can the city accommodate more? And then compared to that, how many people are living then? So that will be the saturation. So let's say the city can accommodate 100 people, and now 50 people are only living. So saturation is 50%. So we should find the let's call it residential capacity. So what will be the capacity? So presently 16,000 are living. So that is true. 16,000 people are living presently. How many more can live? So we have 145 vacant area. So that will be 145 into RD. RD is what? The residential density. So if this many people can live in per unit square, so if we have some vacant land, this many people we can accommodate there also. So this will be 145 into 59.25 plus this is coming as around 2459 uh, use it again 24592.6. That is the capacity. So now if we need to find is it residential saturation. So this we have to find in percentage. So how many people are living presently? 16,000. And so I will write the formula here. So total population into 100 by the capacity. So how many are living presently? 16,000 into 100 by, let's take it as 24593. It is coming at around 65.06%. Yeah, there is 65. We can round it up to 65. So this is the answer. So I think 65 was the answer by you also. Okay, correct. Moving to the next question, question 14. So the data is the same. So now what we are saying is, so all the data is same, but we are saying 20 years after the forecasted population of the area is 22,678. So we have to find that how much of this extra population will be allocated to zone 2. So I'll give 2 minutes. You can try this question out. Any response? Okay, let's try the problem. I think your answer is close enough. It is not exactly close, but we'll see. So we have the column. So what is the original population? 16,000. Forecast population is 22678. So how much is the extra part? So extra is 22678 minus 16,000. So this will be around 6678. So this much population is extra. So this population, where will it go? So this much area people are already living. So this we will assign to the vacant area. So we can say extra population in zone 2 will be the area of zone 2 divided by total vacant area. So if there is, if we have 1000 extra people, we have two zones, 50%, 50%. So 500 people will be allocated to zone 1, 500 will be allocated to zone 2. But here we have different areas, so we have to find the ratio of zone 2 to the total area. Then we can operate this with the extra population for all zones. This is, let's call it EP for all zone. So area of zone 2, that is the vacant area we are talking about. So that is 55. Total vacant area 145. How much is the extra population? So 6678. Check it again. So we have, if I need to find for zone 2, so it's coming out as 533.03. So around 2533 become. Let's mark the answer. So we had a certain extra population based on the ratio of area of different zones. We allocated it to zone 2. Coming to question 15. Which of the following are some of the basic considerations in freight planning? Capacity of transportation infrastructure, safety of freight movement, potential impact on the environment, and land use patterns. I'll give maybe 1 minute. You can try and let me know the answer. Okay. So here, so we need to consider what are the considerations in the freight planning. So first we have to take into account the capacity of the infrastructure. So how many vehicles can flow through in an hour? So we have to consider that obviously. So A is correct. Safety of freight movement we have to consider because how trucks behave on road is different from what how cars behave because trucks will have load. So possibility of overturning is high. There should be vertical clearance, lateral clearance. So these things should be considered. So safety of freight movement needs to be taken care. And we have impact on the environment because the trucks generally give higher emissions. So during the daytime when the public is using that time, the trucks are restricted. So C is correct. Land use pattern will also matter because where the terminals are for loading and unloading, where the commercial areas are, where the industrial areas are. These things will also need to be considered while we are doing freight planning. So all the options are correct. A, B, C, and D. All the options are correct here. Coming to question 16. Which of the following statements are true regarding urban goods movement demand? A unit is one which receives inputs and dispatches outputs. Household may consume certain commodities and produce garbage as output. Commodity requirements for all types of units are same. Economic activities of production and consumption creates good movement. May I have a response for this? Okay, A, B, and D. Fine. So, which of the following statements are true? So, a unit is one which receives inputs and dispatches outputs. So, this is correct. So, you should see the slides for this. The definition was given for what is a unit. Households may consume certain commodities and produce garbage as output. So, this is also true. A, B, we don't need to have transportation planning knowledge for this. This is obvious. So, commodity requirements for all types of units are same. So, this is not true because depending upon what is the unit, commodity requirements can change. So if it is a mobile phone store, so they don't need a truck. Even a small light commercial vehicle can suffice. But if there is a industry where it needs cement, so a small LCV may not be enough. It will need a truck. So depending upon what is the type of unit, commodity requirements change. The type of vehicle will change. So the goods movement will change. So we can remove C. Then economic activities of production and consumption create goods movement demand. See, wherever goods will get consumed or produced. So depending upon that, goods movement will take place. So D is correct. So A, B, and D are good. So option A unit is one which will receive input and dispatch output. Household may consume certain commodities and produce garbage as output. Economic activities of production and consumption will create goods movement demands. A, B, and D are. So this is question 17. So we have been given a urban area of 4 traffic zones. The employment vector is given. So there are 4 elements. Basic employment vector is given. So we have been given A, we have been given B. So what is the initial allocation of service employment in zone 3 as per Lowry's model? So we have to know Lowry's model to solve this. I'll give maybe 3 minutes for this. You can try and let me know the answer. Since there is no response, we'll start with the answer. So let's see what we have been given. So here we have to use Lowry's model. So first we have to find the value of P. So P is given by E into A. So this is here we will take E as the total employment vector and A we have here. So P will be E, that is 120, 150, 50, 173, A 0.27, 0.18, 0.14, 0.15. I'll just write it quickly. 0.14, So we have the values. So for someone who is not very fluent with matrices, so here we have one row and four columns. Here we have four rows and four columns. So this four will go with this four. So we will finally get a matrix of 1 into 4, that is one row and four columns as the final matrix. So it will be a row matrix basically. We'll have one row and there will be different elements. So how will we do? We'll first take this whole matrix, take the product with column 1, then we'll take with column 2, column 3, column 4. So first element with first element, second with second, third with third, fourth with fourth, and then we'll add everything. So we'll start. So I'll not show the full calculation here because there's not enough space to show it here. So I would say, so 120 into 0.27 plus 150 into 0.18, 50 into 0.14, and 173 into 0.14. So we are getting 90.62. So we can write it as 91. So this row with first column is done. Let's do with C2 now. So 120 into 0.18, 150 into 0.27 plus 50 into 0.07 plus 173 into 0.18. This will give us 96.74. Let's take it as 97. Second element is done. Now let's do with C3. 120 into 0.14. So this is 82.94. So let's write it as 83. Now we have to do with last one, that is C4. Here 94.52, it is 95. So this is P is equals to EA. Now we have to find the value of e to the power s. Then only we can get the service employment. So that will be P into B. So we found P. Now we have to take its product with B. So e power s is PB. So P is nothing but 91, 97, 83, 95, and we want so 0.1. So we have the matrix. So P into B. Now let's take the product. So same case, we have 1 cross 4, we have 4 cross 4. So finally we'll get a 1 cross 4 matrix. So 91 into 0.1, 97 into coming out as 24.91. So we can write it as 25. $26.87. Let's take it as 27. So we have done with two elements now. Let's do for the third one now. 22.43. Let's take it as 22. Let's go for the last. So here also we are doing column wise C1, C2, C3, C4. So now we have to do for the last column. 83 into 0.07 plus 9, 20.95. So that is 21. And now what we need was zone 3. So zone 3 will be simply the third element because we have four zones. So this will represent zone 1, this will represent zone 2, zone 4. So the answer is 22. So in exam it is suggested that whatever zone you want, just do for that column. So here we wanted for zone 3. So simply we should have taken all this and we should have done with column 3 and we would have got this element. No need to find these values because these are not required. So that's how you should approach in exam. This was the last question for today's session. If you have any doubts, you can ask. Else, we'll close it in another 2 minutes since we are already close to the time. Okay. So in case there are no doubts, we'll close the session now. Thank you for attending the session. See you next.